Now we're going to look at correlation and linear data. So when two sets of data are strongly linked together, we say they have a strong correlation. And in statistics, this is one of those words, correlation, that has a specific mathematical meaning. So we're only going to use that phrase in this exact context. So we don't want to use correlation and anything else, just with this topic. So the word correlation is made of co, meaning together, and relation, indicating relationship. So correlation is positive when both values increase together. Correlation is negative when one value decreases as the other increases. So the formatting got a little wonky here, but we would say this first one is a perfect positive, and this last one is a perfect negative. They're in exactly a line. Then I go to something strong positive. They're pretty close to a line, or strong negative. And then as we go, we get a little bit weaker. So you could tell still generally going up or generally going down, but they're a lot more spread out. And then in the middle, I just don't really have any sort of correlation, not really going in either direction. And correlation goes between the values of -1 to +1. So in the middle, 0, that would be no correlation. -1 would be perfect negative. That means it's an exact line, like you've studied a lot in algebra. Perfectly positive. And then we have like some cutoffs, and it really depends on, the mood of the day, which one we would say. Some textbooks say -0.7, some say -0.8. So we would say here is strong. And maybe around -0.6 and +0.6, we would say moderate. And then we kind of go to weak. Usually, they'll give you something really strongly one way or the other if we're talking about numbers. The strongest correlation is 1. The values show how good or how strong the correlation is, not how steep the line is. Okay, so not slope. It'll tell you if the slope is positive or the slope is negative, but it's not the value of the slope. It's not the rise over run. So what is linear regression? Unless my correlation coefficient is -1 or 1, the points do not exactly fit a line. But it's helpful if I can't, they obviously have a relationship, so it would be helpful if I could use it to predict different things. So we can find the line of best fit or the least squares. I didn't give you the right number of boxes. Least squares regression line. What does the squares have to do with? Don't worry about it right now. And we can calculate this on the calculator. So here are some beautiful calculator steps. Now, this first step, you only need to do one time after you've cleared your calculator, and it'll stay on. Why don't they just have this as a default turn on? I have no idea. And this is so that I can see my correlation coefficient, which I don't think I mentioned, is represented with an R. If you don't see R when you do the last steps down here, that means you need to turn your diagnostic on. So we press second 0, which gives me the catalog. Then you go alpha D, or you could just scroll for forever to go to diagnostic on and press enter. Your screen should say done if you do it correctly. Once again, all this does is make it so when I find the regression line, it will also show me R. So inputting data is the same as one variable stats, stat, edit, but now in addition to L1, I also am going to put stuff in L2. So my independent values, or my typical X values, go into L1, and my Y values go into L2. And you want to make sure that these are making rows that match with your data points, kind of going horizontally if it's given to you in a table, or ordered pairs if they give you points. Usually in statistics, they'll give you a table. So to find our line of best fit, we stat, edit, plug your numbers in, stat, calc, lin regression, which also corresponds to number 4. So stat, calc 4, or scroll down to linear regression, lin reg. And A is in this place of your slope, and B is still hanging out as your y-intercept. So it's a little different because instead of M, it says A. Really, we should just change to doing A, but that's another conversation. Press enter, and it should give you your A, your B, your R, and R squared. We'll worry about R squared later. All we're talking about today is our line and our correlation. The last thing we love to do in statistics is interpret. So many interpretations. I call statistics copy and paste math because you're going to copy and paste this phrase if they ask you to interpret the slope, or this one if it asks you to interpret the y-intercept. And we need to add an approximately in here. So on average, as the x variable increases by what your unit is on x, the y variable then increases or decreases by, put in a big approximately here, by approximately what your slope is with your y units. Units. When the, for y-intercept, when the x variable is 0, the y variable is blah-de-blah, y-intercept with your y units. So we call this approximately right here is a wiggle word, which they always look for when they're scoring AP statistics for response questions. So make sure that we're including our wiggle words there.